You ever open up a map on your phone and just stare at that little blue dot? You know the one. It follows you around, stops when you stop, and knows exactly which street corner you're on. It honestly feels like magic, but it's not. It's an incredible feat of engineering, and we're going to break down exactly how it works.
So, how does it really happen? How does that little device in your hand talk to satellites orbiting thousands of kilometers above us to put you right on the map with such crazy precision? Well, it's a story of time, distance, and some seriously clever math.
And believe it or not, the whole story really starts with one single simple number. That number is 4. It's the absolute key to getting a solid lock on your position.
Okay, so to get started, your phone needs to hear from at least 3 satellites. By measuring how long it takes a signal to travel from each of those satellites, your phone can basically triangulate its position. This gives you a 2D fix, your latitude and longitude. You can think of it like putting that little dot on a perfectly flat piece of paper. But here's the thing. We don't live on a flat piece of paper. We live in a 3D world, right? And that is where the 4th satellite comes in. This is the real game changer. This is what takes you from being a point on a grid to your actual spot in the real world. So what makes this 4th satellite so important? Well, it does a couple of huge things. First, it adds your altitude to the equation. So now your phone knows if you're on the street or 20 stories up in an office building. And second, and this part is just wild, it corrects for tiny, tiny errors in your phone's clock. See, these signals travel at the speed of light, so even a nanosecond error can throw your location off. That 4th satellite acts like a master clock, syncing everything up perfectly and making your position way, way more accurate. We keep using that word accurate, but what does that really mean in the real world? Are we talking accurate enough to find a city, a building, or like the very spot you're standing on? Well, it turns out it's all a game of decimals. When you see your location as a set of coordinates, those super long numbers for latitude and longitude, the secret to how precise your location is hidden in how many numbers come after that decimal point. Check this out. This table really puts it into perspective. With just one decimal place, your location is only accurate to about 11 kilometers. So you're in the right city, maybe. Add a second decimal, and now you're down to the right neighborhood. But look at this jump. At 4 decimal places, we're talking about an 11-meter range, about the size of a big building. And at 6 decimal places, we're down to 11 centimeters. That's about the width of your hand. That is just incredible precision. And this makes total sense in the real world. For something like a delivery company tracking its trucks, getting down to a few meters or even a few centimeters is all they need. That's the difference between knowing a truck is at the right warehouse versus knowing it's at loading bay number 3. Now, we all just call this GPS, right? It's become the go-to term. But is that the whole story? Are all of these satellites flying overhead part of that one American GPS system? You might be surprised. The reality is actually so much bigger than just GPS. What our phones are really tapping into is a massive, globe-spanning network of different positioning systems, all working together. The correct name for this whole shebang is GNSS. It stands for Global Navigation Satellite System. You can think of GNSS as the general category, and all the different systems are like specific brands inside of it. And there are some real heavy hitters in this game. Of course, you've got the US's GPS with its 31 satellites, but then you have Russia's system called GLONASS. The European Union has Galileo, and China runs Baidu, which actually has the most satellites up there. Altogether, we're talking about more than 100 navigation satellites constantly circling the Earth. Now, as you can imagine, getting all these different systems run by different countries to play nicely together is a huge job. It takes a ton of international cooperation. Technical groups like the ITU, the International Telecommunication Union, work to coordinate everything so the signals don't interfere with each other. It's a pretty amazing example of global teamwork. So what does this all mean for the phone in your pocket? Well, it's not just looking for the bare minimum of 4 satellites. Nope. At any given moment, it's probably locked on to somewhere between 7 and 12 satellites, and often it's a mix from these different GNSS systems. So why? Why bother connecting to so many satellites from so many different countries? Well, it all comes down to a really simple idea. When it comes to satellite navigation, more is definitely better. Having access to this huge global network gives you some pretty sweet benefits. For one, it helps you get a signal even when things are blocking the way, like if you're walking between skyscrapers in a big city or hiking in a dense forest. More satellites in the sky means a better chance one has a clear line of sight to you. It also helps correct for little errors caused by the signal traveling through our atmosphere, and, most importantly, it just makes getting that first lock on your position way faster and way more reliable. At the end of the day, this whole massive, globally coordinated dance is all about one simple thing: getting you a faster, more reliable, and more accurate position fix every single time you need it. So the next time you see that little blue dot pop up on your screen, you'll know. It's not just one thing, it's the result of a quiet conversation between your phone and maybe a dozen satellites from different countries, all working together to find you with mind-blowing precision. It really makes you wonder, now that our phones can find us down to the width of a hand, what are we going to navigate next?